Hi, welcome back. In this video, we're going to focus on what we learned in week 2, which is concentration measurements. There are 5 concentration measurements in this subtopic. Before you can do the calculation, basically you need to remember the definition of each of these concentration measurements. Then to keep in mind that when you remember the formula, please include the solute, solvent, and solution. Okay, in the definition. Please don't ignore these 3 terms, which is accordingly. At the same time, you also need to remember the unit because the unit is very specific. For example, molarity is mole of solute over volume of solution in the unit of liter. So again, this is what we emphasized just now. We need to include the term solute, solvent or solution accordingly, and also the unit. Okay, so the definition is very important and you already remember. So before we can go and answer the questions, you need to know to differentiate solute, solvent, and solution. So basically, solution is a homogeneous mixture between a dissolved solute and solvent. So solute in bahasa is called zat terlarut, and then you can add some pelarut inside, then it will hasilkan a larutan. So in general, solute normally will have smaller amount compared to solvent. However, if it is a concentrated solution, it may be the other way around. So from the question, you have to focus on the term dissolve. Okay, so then you will know whether the substance is solute or solvent. Okay, now let's answer the question. Before we can answer the question, like just now we mentioned, we need to know how to differentiate solute, solvent, and solution. A 250 ml 2.0 molar NaCl solution has a density 1.077 gram per ml. So means that this density is density of solution. Okay, so from the question now here we know that the NaCl is the solute. So if the question didn't mention others compound, so basically the solvent will be the water. Okay, then next the question asks us to calculate the molarity. So basically when we want to answer this question, step number 1, we have to list down the formula of the molarity. Okay, if you can list down the formula of the molarity, means that you can remember the definition, which is mole of solute, in this case is NaCl, over mass solvent, which is water, in the unit of kilogram. Then now at the same time we also will list down what are given in the question. Question given us 2.5 molar, which is mean molarity equal to mole of NaCl over volume NaCl solution. So molarity given 2.0, number of mole unknown, volume of solution is 250 ml. But if you remember just now I say when we memorize the formula, we have to include the unit as well, since the volume of Na solution supposedly is the unit of liter. So even the question gives us in 250 meter, we still know can convert it to liter, which is 0.25 liter. From here, then we can have the idea that mole of NaCl is equal to 2 mole per liter multiply with 0.25 liter. So liter and per liter cancel out, which will equal to 0.5 mole. Then from here, you can substitute the number of mole into the formula. Next, we need to determine the mass of H2O. So from here means that we have another information haven't been used yet, which is the density. Okay, so we rewrite again. The molarity is equal to mole of NaCl over mass of H2O in kilogram. So in the previous slide, we already have the idea how to determine the number of mole of NaCl. Then next, we are going to use the density to determine the mass of water. Okay, so let's see how we can use the density of solution determine the mass of water. Yeah, so density of solution is equal to mass solution over volume solution. So in the question, density is given 1.077 gram per mole. And then the 250 ml of NaCl solution means that this is the volume of the solution, 250 ml. In this case, we no need to convert the unit because per ml and ml can be cancelled out. Then we will get the mass solution. So after we get the mass solution, we are not going to substitute the value in. Okay, so the mass solution, which is 1.077 multiplied with 250, which equal to 269.25. Okay, which is 269.25 gram, which is the mass solution. So we need to determine the mass of water. Then as we know, mass solution always equal to mass NaCl plus mass H2O. So if we want to determine the mass H2O in this case, we are going to use mass solution, which is 269.25 minus the mass of NaCl. So just now we already have the idea. The number of mole of NaCl is 0.5 mole. So we multiply with the molar mass, which is 23 plus 35.5 plus 35.5. From here, you will get the mass of water, which is in the unit of gram. But then do remember that you have to convert to kilogram. Then you can substitute in here and you can get the molarity. So from this question here, you will notice that you no need to do assumption because there is only one unknown in the formula. For example, the density of solution, we only have the unknown, which is the mass solution. So I think as long as you can remember the formula, then you can answer the question 11b as well. For your information, this question is in the tutorial, so you can get the final answer in the tutorial book. Now let's check with another question, which is also no need to do assumption. Okay, this is an aqueous solution is prepared by diluting 3.3 ml acetone. So this is the chemical formula for acetone with the molar mass 58 gram per mole. And then with a bracket density equal to 0.789 gram per mole. So basically this is the density for the acetone with water to a final volume 75 ml. So this 75 ml basically is volume of solution because you add 3.3 ml acetone with water, end up the final volume is 75 ml. So and then the density of the solution is 0.993 gram per mole. what are the molarity. So again, when we list down the formula, molarity is number of mole of acetone over volume of acetone solution in the unit of liter. So in this question, because we have the volume and we have the density. Okay, so as we know, density acetone equal to mass acetone divided by volume acetone. Since we have the volume and the density, so we will able to determine the mass acetone, which is 0.789 multiplied with the volume 3.3 2.6037 gram. So with the mass, then we will able to determine the acetone, the number of mole of the acetone using 2.6037 gram divided by 58 gram per mole. Gram and gram cancel out, and out the unit is mole. Okay, then we already have this answer. And then the volume of the acetone solution, which is the 75, we substitute in, but remember that we need to divide by 1000. So again, when you notice that you want to use a formula and there is only one unknown, means that we are not going to use assumption. So I will stop the video here. In next video, we will discuss another few questions which you need to do the assumption. Thank you.